Okay, the first things we clock in this question are, firstly, we're going to have to use some small angle approximations, and secondly, we're going from first principles. Oh, and it's trig. Okay, so what do small angle approximations tell me? Well, these are in the formula book. The formula book tells me that for small angles, sine of x is approximately equal to x, and cos of x is approximately equal to 1 minus x squared over 2. So I've got those to reach for when I need them. Okay, and I've got to use first principles, and the formula for that is in the formula book. It says that f dashed of x is if it exists, the limit as h tends to 0 of f of x plus h minus f of x all over h. Okay, so but this is just stuff copied out of the formula book. So I have to do differentiation from first principles, and my f of x is going to be cos of 3x. So let's start there. F of x equals cos of 3x. So if I'm going to put this together, okay, I can work out f of x plus h, which is cos of 3 brackets x plus h. So f of x plus h minus f of x all over h. I'm going to leave the limit for later. F of x plus h, that should have said, minus f of x all over h equals this one here. Okay, so I'm going to actually make that into cos of 3x plus 3h, I think, minus cos of 3x all over h. Okay, so how am I going to deal with this? Well, I'm going to have to expand this using addition formulae. So the formula for cos of a plus b is cos a times cos b minus sin a times sin b. So I'm going to get cos of 3x times cos of 3h minus sin of 3x minus times sin of 3h minus cos of 3x all over h. Okay, but the small angle here is 3h, so my cos of 3h, this tells me that I can replace that by 1 minus 3h all squared is 9h squared over 2, and I can replace my sine of 3h by 3h. These approximations are good for small values of h, and of course I'm going to be doing a limit as h tends to 0 later on, so the closer h is to 0, the better the approximations get. So this is approximately, okay, okay, so this is going to be cos 3x times 1 minus 9h squared over 2 minus sine of 3x times 3h. Okay, and then I'm going to have minus cos of 3x. This is all over h. Okay, that's maximum complexity, and I can see that what's going to happen when I expand this out, I'm going to get a cos 3x times a 1, and that's going to cancel this minus cos 3x, so that's going to vanish. And the remaining terms I get can be divided by h. So this equals, okay, I've got a 9 over 2 times h squared times cos 3x divided by h, so that's going to be 9 over 2 h times cos 3x, and then this term is just going to be minus 3 h divided by the h is cancelled, times minus 3 sine 3x with the h is cancelled. Okay, so that is f of x plus h minus f of x all over h, approximately. Okay, so therefore the limit as h tends to 0 of f of x plus h minus f of x all over h is the limit as h tends to 0 of this thing I just cooked up, the 9 over 2h cos 3x minus 3 sine 3x. But this first term in it, which has the h in it, as h gets towards 0, this term here is going to tend to 0. So the answer is just minus 3 sine 3x, which is, that process is the process for finding f dashed of x, and it was a show that, so this is as required. I've convincingly obtained the correct answer. Hooray.